A climate model is a representation of the physical, chemical, and biological processes that affect the climate system. Models also include natural processes like changes in the Earth's orbit, historical changes in the Sun's activity, and volcanic forcing. Models are used to estimate the degree of warming future emissions will cause when accounting for the strength of climate feedbacks, or reproduce and predict the circulation of the oceans, the annual cycle of the seasons, and the flows of carbon between the land surface and the atmosphere. The physical realism of models is tested by examining their ability to simulate contemporary or past climates. Past models have underestimated the rate of Arctic shrinkage and underestimated the rate of precipitation increase. Sea level rise since 1990 was underestimated in older models, but more recent models agree well with observations. The 2017 United States published National Climate Assessment notes that climate models may still be underestimating or missing relevant feedback processes. Additionally, climate models may be unable to adequately predict short-term regional climatic shifts. A subset of climate models add societal factors to a simple physical climate model. These models simulate how population, economic growth, and energy use affect and interact with the physical climate. With this information, these models can produce scenarios of future greenhouse gas emissions. This is then used as input for physical climate models and carbon cycle models to predict how atmospheric concentrations of greenhouse gases might change, depending on the socio-economic scenario and the mitigation scenario. Models produce atmospheric CO2 concentrations that range widely between 380 and 1400 ppm. The IPCC Sixth Assessment Report projects that global warming is very likely to reach 1.0 degrees Celsius to 1.8 degrees Celsius by the late 21st century under the very low GHG emissions scenario. In an intermediate scenario, global warming would reach 2.1 degrees Celsius to 3.5 degrees Celsius, and 3.3 degrees Celsius to 5.7 degrees Celsius under the very high GHG emissions scenario. These projections are based on climate models in combination with observations. The remaining carbon budget is determined by modeling the carbon cycle and the climate sensitivity to greenhouse gases. According to the IPCC, global warming can be kept below 1.5 degrees Celsius with a 2/3 chance if emissions after 2018 do not exceed 420 or 570 gigatons of CO2. This corresponds to 10 to 13 years of current emissions. There are high uncertainties about the budget. For instance, it may be 100 gigatons of CO2 smaller due to methane release from permafrost and wetlands. However, it is clear that fossil fuel resources are too abundant for shortages to be relied on to limit carbon emissions in the 21st century. Even though the temperature will need to stay at or above 1.5 degrees Celsius for 20 years to pass the threshold defined by the Paris Agreement. A temporary rise above this limit also can have severe consequences. According to the World Meteorological Organization, there is a 66% chance that global temperature will rise temporarily above 1.5 degrees Celsius in the years 2023 to 2027.